Alright, so today it's super fun. Did you see that first word?
No. Oh, prove.
Proving!
That's so stupid.
I got
Yay! Okay, so you do have like a couple of legit like two-column proofs, but most of it is just kind of the process of proving. Guys, I love me some proofs. Okay, anyway.
Leave me alone in that then.
As a reminder, back to all of these happy memories of proving and doing proofs with triangles. Okay? So when we did proofs with triangles, we were typically proving that two triangles were congruent. Today we're talking about two triangles are similar. Now, when we were proving that two triangles were congruent, we had 5 postulates or theorems that we could use to prove two triangles are congruent. So we had side, side, side. So if you had 3 sets of congruent corresponding sides congruent, the triangles were congruent. We had side, angle, side, angle, side, angle, 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 side, and hypotenuse left. Okay, those were the 5 ways. That if you knew if you could satisfy any of those conditions, that was enough to prove that the triangles were congruent. So we have just 1 postulate, 2 theorems for how to prove that two triangles are similar. All right, so remember, similar, same shape, not necessarily the same size. So the first one is a postulate, postulate 7-1, and postulate 7-1 is the angle similarity postulate. So when we were proving triangles were congruent, we did not have an angle. We had side, 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 but not an angle, because, I mean, you can see in this picture here that you could have an angle, one bigger than the other. They're not congruent, but it turned out that they are similar. Now, it actually turns out that you don't even need 3 angles, you just need 2. Anybody know why?
Because they're congruent.
Yeah. If you have angle, you are going to have angle.
Yeah.
Right? Because if the 2 are congruent, that third one has to be congruent. So you only have to have 2 angles because that third angle is going to be congruent no matter what. So as far as proof purposes go, you just have to have those 2 angles. Okay? Alright, so the angle similarity postulate says that, okay, if we have angle S congruent to angle M and angle R congruent to angle L, I have 2 sets of corresponding congruent angles. That's enough to prove that triangle. We could say maybe SRT is similar to, remember from yesterday, the order of the letters doesn't matter. Since S comes first, M would have to come first, and then we'd have to do LP. So that's one, just 2 angles. That's probably the one that takes the least amount of information. We have 2 sets of corresponding angles. Okay, the next one is side, angle, side. Now, we had side, angle, side for congruency. The biggest thing with the side, angle, side is you have to, I think about it, you have to go in order. It has to be a side, then an angle, and then the side on the other side of the angle. So that angle needs to be included between the 2 sides. Now, for congruency, the angles, the corresponding congruent angles, they had to be congruent. The sides that made up the angle also had to be congruent. So if you had an angle congruent to an angle, and the sides that create that angle are also congruent, that was enough to prove the triangles are congruent. It's going to be similar with similarity, but not quite, okay? You are going to have a congruent angle. So in this case, if I have angle A congruent to angle Q, there's your angle, and you're still looking at the sides on either side of the angle. So notice I have, if I'm talking about angle A, I have AB and AC, okay? And over here, if I'm talking about angle Q, I have QR and QS. It wouldn't have anything to do with BC or RS. Okay, so I'm talking about the sides that create that angle. Now, these sides, and you can see in the picture, but these sides, AB and QR, they're not the same. They're not congruent like they would be with congruent triangles. But remember the properties we talked about yesterday with similar figures. If these are similar, they would be proportional. So it would be enough to prove that these triangles are similar if you have the congruent angle and if AB to its corresponding side, which is QR, if that ratio equals AC to QS. So if you have a side angle side where the angles are congruent and the sides that create the angle are proportional, that's enough to prove that the triangles are similar. And then we also have a side, side, side. Now, we had a side, side, side for congruency, where if you had 3 sets of corresponding sides that are congruent, that was enough to say, okay, these triangles are congruent. Similar with similar triangles, but they're not going to be congruent, kind of like the last one, they're going to be proportional. If you have a figure and you have 3 sets of corresponding proportional sides, that's enough to prove the triangles are congruent. So like if I had AB to QR, whatever that ratio is, would have to be equal to, if we do AC to QS, and then BC to RS. If you can prove, and we kind of did this yesterday, right? We knew, okay, are the triangles similar? Do they have sets of similar sides? That would be enough to say yes, they are similar. Okay, so that's the big thing we're going to be doing today is deciding whether things are similar or not. So what we're going to do, we're going to decide if they're similar. If they are, we will write a similarity statement, and then we will explain how we know they're similar. For your explanation, it's either going to be the angle, the side angle side, or the side, side, side. Now, if I look at this first one, to do angle, or side angle, side, you gotta have an angle. They don't give me any angles. They give me all the sides. So I kind of already know that I'm going to try to prove that these are similar using the side, side, side postulate, which means I need 3 sets of corresponding sides that are proportional. Now, what we would do is, like yesterday, they're kind of oriented the wrong way. So I want to write a ratio, maybe we say from the smaller to the larger, of what I think might be the corresponding sides. So it kind of looks like, right, that 9, that top, it's just kind of flipped over, okay? It kind of looks like those are the corresponding sides there. So maybe it's 9 to 12, like we did yesterday. If I reduce this, we would get 3 to 4. So that's the scale factor that I'm kind of thinking I'm going to use. Now you may notice, hopefully, that these are isosceles triangles. So 6, 6, 8, 8, it doesn't really matter which 6 you put over which 8, you're going to get the same answer. But if you do write that, 6 to 8, and reduce that, you get 3 over 4! And guess what? Whenever you take the other set of corresponding sides, that's also 6 over 8, you're going to get? So I have 3 sets of corresponding sides that are proportional. That's enough. If you have the side, 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 that's enough to say yes, because of the side, side, side similarity. Lots of S's there. Side, side, side similarity. And then we want to write our congruent statement. So, like yesterday, it doesn't matter how you name the first triangle. You can name it however you want. How do we want to name the first triangle?
ABC.
ABC sounds great. Now, for this one, since it's an isosceles triangle, there's kind of some options here. Since it's isosceles, you know A and B are congruent. Since it's isosceles, you know E and F are congruent. So you could, if we start with A, you could either start with E or F. It doesn't really matter. I mean, if I'm kind of going the same way and flipping it over, we might do F, E, G. Not the only way it would work the other way, but maybe you just call it F, E, G. Okay, and then if I go over here to this one. Now, what I think is kind of helpful here, just kind of identifying, here's the triangles I'm looking at, because I'm trying to prove that 2 triangles are similar. So one of the triangles is going to be this little triangle here. That's one of my triangles I'm trying to prove is similar to, where's the other triangle? A.
Yeah.
It's the big one, right? AEC, it's going to be that big triangle there. Okay, now remember, we have three ways. We can either do angle, angle. I do have one angle. Do I have any other angles? Now, what angle am I talking about? I said I have one angle. The right angle, right? I do have that one right angle, but I don't have another angle. I could, anyway. Side, 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 you need all three sides. I said this last class and people got super excited. We could actually technically find that third side. But the Pythagorean theorem, we don't need to do that because, look, yeah, I have side, angle, side for all of them. So that's what I'm going to try to use to prove they're similar. So if I'm going to prove that they're similar, I first need the angle. Do I have an angle congruent to an angle?
Yes.
Yeah, the right angle, right? So I have the angle. Now remember, if this is the angle I'm using, the sides I need to use are the sides that create that angle. It's going to be those sides there. So, however you write your ratio, it doesn't matter if you do small to big or big to small, you just have to stay consistent. If I do small to big, let's start with that left-hand side. This side right here is 6, 2. What's the big side there? 12. Yeah. And 6 to 12 would give me 1 to 2. And then if I go to the top one, once again, since we did small to big, we need to do small to big. What would that ratio be? 8 to 16, which is also 1 to 2. So I have my angle. I have my two sides that create the angle that are proportional. So we could say, yes. How do I know they are similar? Side, angle, side, similarity. And then we need our similarity statement. So it kind of like with the ratios, it doesn't matter if you start with a smaller triangle or the bigger triangle. It does not matter. If I wanted to start with a smaller triangle, how could I name the smaller triangle? Okay, AWL. I know there's others. Okay, but if I do AWL, how will I name the second triangle? AEC. Okay, let's get this glued into page 73. This is section 7.3. Proving triangles similar. Okay, so the first thing we're going to do, kind of what we did on the left-hand side, we're going to decide if the triangles are similar. If they are, we're going to do the similarity statement and then decide how we know that they are similar. So, number 1, we're going to draw a triangle within a triangle. Okay, and starting from the top, and then just coming down that top, it will be M, P, N, and then going to the left will be O, L, and ML is going to be parallel to OP. Parallel lines. Bringing back all sorts of good stuff today, right?
Yeah.
Roofs, triangles, parallel lines, and you guys all thought this stuff was good.
What are we, January?
I know. Okay. All right. Now, keep in mind, we have 3 ways, okay? 2 of them, side, 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 and side, angle, side, you have to know something about the sides. Do I know anything about the sides?
They're congruent.
Right, no, we don't know that.
Parallel.
They're parallel. But as far as lengths go,
No. Not enough information.
we'll get to that, okay? As far as the side lengths go, I don't know anything about the side lengths. So I cannot do side, 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 or side, angle, side. Which means I'm kind of stuck with angle, angle. So the first thing that I kind of like to do is kind of point out the triangles I think I'm looking at. So we've got the little triangle, right? NPO, OP, and however you want to name it. What's the other triangle? Yeah, MNL. Okay, so we're kind of thinking that if I can prove these triangles are similar. Triangles can't be parallel. That's okay.
I'm sorry.
Okay. If they're similar, we're kind of thinking we're going to use angle. So, to start off with, there's one angle that is absolutely congruent that I know. 100%. What? In, right?
Yeah.
Angle in, congruent to angle in, because it's the same angle in both triangles. So I just need one more angle. Leo.
Angle NOP and angle NLM.
NOP and MLN. Okay, so Leo's saying that these are congruent. Why in the world do you think those are congruent?
Because there's one line passing through parallel lines, and then it's like congruency of angles or something.
There we go. Teamwork here. Yeah, these are corresponding angles. Okay, some reminders here.
Thank you.
Okay, because this stuff is going to come up today, okay?
Say what?
So we have parallel lines cut by a transversal. Teamwork here. These are called corresponding angles. Corresponding angles are congruent. So, yes, we do have angle, and actually, you have the third angle as well because those other angles are corresponding angles as well. But we don't need 3 angles, we just need 2. So I could say yes because of angle similarity. And then we need our similarity statement. So it doesn't matter if you do the big triangle or the small triangle first. It means the same thing, but let's start with the small triangle. Who wants to name the small triangle? NOP is similar to NLM. Excellent. Okay, let's do another one of those. Number 2. Okay, kind of the same idea. Going to be a triangle within a triangle. Okay, and this is going to be Q, R, S, T, U. Q, U is 3, U, T is 7, Q, R is 2, R, S is 6. Okay, once again, I think the first thing to do, maybe kind of point out the 2 triangles that I'm trying to prove are similar. So we can do the small triangle. That usually is an easy one to see. Q, U, R. What's the other one? Q, S, T. So those are the triangles that I'm trying to prove are similar. And remember, you have 3 ways, okay? You could do side, side, side. But to do side, 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 you need all of the sides. And I don't have all of the sides. Okay? We could do angle, angle. I got one angle, but I don't have another angle. I also have side, angle, side. Okay, so let's start with the angle. Q, right? See how they both have that Q? Okay, they both have angle Q. Now I need to show that this side is proportional to this side, and this side is proportional to this side, and it's all the same, okay? So, if I start with Q, U, remember you have to take one side from one triangle over the corresponding side from the other triangle. So it would be 3 over
7.
10. Oh, yeah. 3 times the trunk. Yep, the whole thing, right? 3 plus 7. There we go. Okay, that needs to be the same as 2 over
8.
8. Is it the same?
No.
Nope. And since those sides are not proportional, they are not similar. So we have to say nope. And if they're not similar, I cannot do a similarity statement. Okay, I'm gonna give you guys a second to contain your excitement. Because you know what we're getting ready to do?
Approve.
Approve! It's been so long since we've done a proof, and I know you guys are so incredibly excited. Okay, so here we go. Zone in that excitement. Here we go. All right. We're going to have a picture
picture.
like a sideways bow tie, like this. And we're gonna do C, A, B, and then P, M. There's my picture. And I'm getting ready to like bring back all of the good memories. Okay? No, I mean the memories, the good memories. Okay. So whenever you have a proof, you're given two things. You are given the given. Given M P is parallel to A C. Prove. I know I'm good at these guys. Okay. Prove triangle A B C is similar to triangle P B N. Okay, let's get our proof set up. Everyone have a set up what you call proof?
You
Yes.
put a t-shirt and then you put a line through it.
And what goes here?
Given.
Statements.
And reason.
There we go. And reasons.
And
It's
then
all
you put a
coming
line
back.
through it.
And then you put a line through it and a T-chart. Now let's see if you guys remember this one.
Okay.
What's the first statement?
Given.
Given, right? My given is MP is parallel to AC because it's the given. Okay, now the one thing that I don't feel like I stressed enough, I feel like I did, but just maybe not enough, mark your picture. So I'm given that these are parallel, so let's go ahead and mark that they're parallel. Now, before we even write our proof, I think a lot of times we try to get into our proof, we just try to like dive in. You come up with a game plan. Okay? Let's come up with a game plan. Remember, we have our 3 ways that we can prove. But remember, for side, 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 and side, angle, side, you gotta have some sides. You have to have some side lengths. Do I have any side lengths?
No.
No side lengths.
Angle similar to both.
Okay, so I'm thinking it's probably gonna have to be angle, angle. Okay, does everybody understand why we kind of ruled out the side, 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 angle, side? Okay, so I need 2 angles.
B.
The vertical angles and the
There's like 18
PA.
angles at B.
the
A, B, and
one
BP.
MVP is
Angle ABC and MBP
Chill.
is
Okay, so the first one that you guys are seeing. Okay, the first one that you guys are seeing are these angles right here.
Yeah.
yes.
That one.
Okay, I know they're congruent. We'll write this in our proof. We know this is these are congruent because. Okay, let's go ahead. We'll just write that. Okay, so angle. Now, guys, remember for an angle, you can name it with just one letter if that's the only angle there. I can't name this angle B because there's a ton of angles there. I have to use 3 letters. 3 letters to name an angle. CBA is congruent to angle MBP. Because vertical angles are congruent. Okay, great. We've got angle, but I need angle, angle.
Angle A and angle B.
Angle A.
Or M and C.
Okay.
They're better.
Angle A and angle P.
Yeah.
C and M.
And C and M. I only need 2 angles, so we're just going to leave it here. Why?
Because
Alternate
interior.
interior angles. So, number 3. It's like riding a bike, guys. It's all coming back to you. Angle A is congruent to angle P. Now, one other thing to remember, guys. Okay, one other thing to remember. You technically don't need those vertical angles. You could. That's totally fine. But if you just wanted to use the alternate interior angles, if a statement has the same reason, which angle A and angle P are congruent, and angle C congruent to angle M, that's the same reason because they're alternate interior angles, you can combine that in the same step. Okay? In this case, like I said, we only need an angle, so if you want to write that third angle, you definitely can, but we don't need it. Okay, and then why did we say angle A was congruent to angle P? Alternate interior angles are congruent. Okay, now, the first line of your proof is always a given. The last line of your proof
Is the proof.
is always the proof. Do I have enough to say these triangles are similar?
Yes.
Yes. Okay, so the last step is going to be triangle ABC is similar to triangle PBM because
Angle.
you could let in a child!
Oh, angle, angle, similarity postulate.
Angle, similarity. Thank you. Somebody got
Sorry,
it.
someone said what?
You
I
could
heard
let in a child!
What?
Monsters Inc. Come
Oh,
on, guys.
sorry.
Said the I don't know what the line before that is. Something like what was the why would we close the door? Like because you could let in a giraffe. Because you could let in a child. We watch this Monsters Inc.
With the light and stuff, and then you have to fill up the energy bar or the screens. Yeah, that would be.
Okay, all right, back on track. We're almost done. Okay,
Love me.
I should know I'm recording your guys. I'm distracted. Okay, number 4. Okay. Number 4, we are going to decide first how we know that the triangles are similar, and then we will solve for x. Okay, so for these triangles, this left-hand side is 30, the top is 50, the bottom is 80, this right-hand side is x. 80. Yep, 30, 50, 80, x. Okay, first thing. How do I know that they are similar?
Right.
Right angles and vertical angles.
Okay, so I have the right angles,
And the vertical angles.
and I have the vertical angles. So, what postulate or theorem tells me they're similar?
Angle similarity.
What?
Sure.
Yes.
I have an angle and an angle. Right? I have 2 angles. I have the right angle and I have the vertical angle. So angle, angle, similarity. Okay, now I know they're similar, so I now can set up my proportion. Now remember guys, you have to take one side from one triangle over the corresponding side from the other triangle. So what could 1/2 of my proportion, 1 ratio be?
50 over 80.
50 over 80. Those are the corresponding sides. 50 over 80 equals
5 over
30 over x.
30 over x.
What? Oh.
50 over 80 is 30 over
Where
x.
did you get 5 over 8?
Because you reduce it.
Oh, I see where you're going with that. Okay, anyway, we're going to go ahead and flip it across. 50x equals 80 times 30 is 2,400. Divide by
Look how many
50.
zeros are now. Yeah.
We should get 48.